So now continuing with the process of PDB-QT file format preparation. So up till now we have done the conversion of the ligand STF files into the PDB-QT. So the second aspect is the preparation of the protein structure, which we are going to do it either by the different software. So firstly, what we are going to do, we are going to open the soft structure of the 1KRM by using the Discovery Studio. So Discovery Studio Visualizer is actually the one which gives us the much detailed information regarding the protein structure. So firstly, what we will do, we will delete the water molecules, heteroatoms, and the ligands if it has been attached. Along with that, we have to check the different characteristics of the protein. So we are going to open 1KLM PDB. So this is the basic structure of the 1KLM, which is the protein for the HIV. So here we can see that the control panel is not opening. So for that, what we have to do, press Control H. So when we press the Control plus H, H for hers, so what we will see is the detailed structural modification. That is, if I select chain B, so it is going to highlight the chain B. Then this chain A, okay, A, this one, and this one, or the heteroatoms which are present. So you just have observed brightening, water molecules, active sites, protein groups. So these are all the proteins and the ligand. So where is the ligand attached? So when here it is. No? So when we say a ligand is already been attached, so what we will be able to dock the different molecules? No, it's more like we have a door lock and the key is already there. So when the key is already there, we cannot put the other key to check whether it can bind with the same door lock or go into the same door lock. So what we have to do, we have to take out that key so that the active sites or the positions where that key, the other key can be inserted should be free. So same is the phenomena. So that is the reason that here we are going to delete these ligand groups. So there are two ways, either go by right clicking the ligand and remove the group, or the simplest way is just click on the ligand and press delete in your keyboard. So we have to delete the water molecules, the heteroatoms, as they are going to interfere with the virtual screening. Along with that, we have to minimize this structure. But what is the reason we are not doing it right now? Because we are not aware which site or which chain A or B is having the active site. So for that, what we have to do, we have to identify the active sites. So there are two basic ways of identifying the active sites, either with the literature review or by going to the PDB sum or some other methods where we are going to identify the binding pockets by using the different web servers. So the most common is the literature review, examples of which I have shared these two articles at the group. This one, which has the reference coordinates, in this one, the details has been mentioned. Just like over this active site-based molecular docking was performed by AutoDock 4, and what they have find out, the active sites includes ASP 92, 93, 94, and this is the sequence of the protein which had amino acid which is present into the 7Y14 with the grid box coordinate, and these are the coordinates which are actually required at the configuration file generation. So what we said, for the sake of the configuration file, we need to have the active sites, and when we have the active sites, then we will be able to identify these XYZ coordinates, and these XYZ coordinates are the one which is going to identify or mark the dimension of the grid box. And what is the grid box? A grid box is just like a mark that the active site is there. For example, when we say okay, someone has to come to meet me at, so okay, we can say okay, come to OJA. So where in OJA, because the campus is so big. So when I say okay, Dara College of Pharmacy, so there we have actually generated a grid box that the Dr. Sana Shamim will be somewhere in the Dow College of Pharmacy, and there you can find much easily. So that Dow College of Pharmacy is actually like a grid box in the OJA campus where you will be able to identify, okay, she will be present somewhere in this college. So these coordinates identification by the identification of the active sites is going to help us in identifying the size of the grid box so that the drug can bind over here rather than wandering all around into the like a campus. You have a specific area where you can find out. So the this is the first reference article. Another reference article, they also have mentioned these XYZ coordinates. But in most of the cases, in most of the articles, there is XYZ coordinates has not been mentioned, which inhibit or prevent the repetition of the reproducibility of the work. So the NASA Open Sciences or their program is actually based on this aspect. Whenever you are going to publish or you are publishing your work, it should be like reproducible and repeatable by anyone in the world by following the same parameters which has been mentioned. So when you don't mention the active side, when you don't mention these XYZ configuration file requirements, you are actually covering something and you are not giving the whole information regarding the molecule. So these are the two basic aspects. So the most important that we are stuck right now here. So that is the protein which we have selected is not giving us the information regarding the protein or the active site. So there is another aspect where we can go to the PDB sum, which is the pictorial database of the 3D structure in the protein database, the structures which has been reported in the PDB. So here what we are going to do, we are going to give the name of our protein and let him find. So now this is the detailed protein structure where all these aspects that how many chains are there, how many enzymes can act on these molecules. And this is the abstract of the work where this protein structure was reported firstly. So on the top of panel, what you will be observing, there is a ligand. So when you say ligand, SPP is actually the one which has been attached with the structure of this one KLM. So it will give us the structure. This lick plot is actually the one ligand plotting after interaction with the uh, amino acid or amino acid. So here we can see that this is the SPP. This is the basic structure of the molecule. And these are the amino acids which are involved in binding or interacting with this 1 kLm. So what we can do, okay, we can identify, for example, we have observed one lysine 103A. Now this is clearly indicating that chain A is actually the one which is responsible in binding with a receptor, or we can say this is the one which has the basis of interaction. So what we will do over here, we just keep the chain A and delete the chain B. So now our protein is very much prepared. But when we say that chain A may lysine 103, okay, now we have to go to the lysine 103. This is lysine 103. So when we click it and then right click, go to the base where they have written attributes of lysine. So these are the one which need to be copied. So what we will do, we are going to copy it and we are going to open the Excel. Because this is not the only amino acid which is involved in the active site identification. So what we have to do, we have to take all the amino acids and put these values over here. So these are the XYZs of our receptor. And they are the one which are binding with the protein. So minus 3.629889, and the other one is okay. So we have identified the attributes from here, and the other protein which has been involved is like this threonine 227A. So we will go to the 227A. So PHE 227A. So in this aspect, we are going to take the attributes of all the amino acids, minus 6.8. So we have to write X, Y, C, right. C, 0, and the interacting is this tyrosine 318A. So we are also going to get the attributes of the tyrosine 108. Three one eight. Okay, sorry. Yes. And then again right click and get the attributes. Okay, minus 3.885. Thirty point 187. Thirty point 187. 17.63. 17.63. Minus 32.56. 28.60. So after having this, what we have to do, we have to take the mean. So for that average of all these, enter. So what we get is the average of x, y, and z coordinates. So these are the one which we are going to put into the folder of the configuration.txt. So what we got, minus 4.798, minus 4.798, 12.09, 12.09, and 21.6. Okay. The size of the box will remain same, and we will go with the same number of modes. Okay. So now just click Control S. It has been saved now. We don't need this. So right now we are not saving. So in this way, we will be able to identify that the protein structure or the attributes. So after deleting water molecules, hydrogen atoms, ligands, and the extra side chain, we have got the much better structure. So what we are going to do, we are going to save it as one KLM clean. Just to keep it in mind that we have done the cleaning and we are not going to save it in the Discovery Studio. Rather, we are going to save it in the PDB format. So now this 1KLM clean.pdb is going to differentiate between the protein structure which we have downloaded and the structure which we have modified. So right now we don't have to use this one. Rather now I'm going to open the AutoDock tools. So what we will do now that we are going to add the hydrogen, the polar one only, and the color one charges, which are actually the basis requirement for producing the simulation with the ligand structure. So in this way, sorry, not with the protein structure. So we are going to open that clean molecule over here and of the receptor, and then we are going to add the polar hydrogen and the polymer charges. Five, read molecule. In AutoDock tools, read molecule means they're talking about the protein structure. So file, read molecule. So we have it on the desktop, virtually scrolling folder. And now we have this 1KLM clean. Now we are going to open it. So when we open the 1KLM clean, so firstly, we have to go to the edit, charges. Sorry, firstly, we are going to add the hydrogen, add. So it is going to ask which type of hydrogen we are going to add. So we are saying we just want to have the polar one. Click OK. So what you have observed, these white dots that the water molecules has been added. Now again go to edit, charges, add column and charges. This pop-up will appear. It is indicating that in order to neutralize or to make the drug a little bit of ionized, they have added the column and charges. Now we can say OK. So now file, save, write it as a PDB, browse. So the file name is 1KLM edited. Okay. Yeah, 1 km clean underscore h dot pdb. So still it is in the PDB format. So where we are going to save again in that same virtual screening format. So okay. Then we are going to open this grid macromolecule. Open. So we cannot see it. Right now. We just have saved it in the same folder. So what is the issue that file type selected over here is the PDBQT. Now, while the file which we have saved is actually in the PDB. So when we select this PDB, okay, now we can set this 1 km underscore clean is there. So we are going to click it. Now it is saying by clicking the grid, opening that 1 km clean underscore h, now it has given us the PDBQT format of a protein. So where we are going to save it in the virtual screening folder, 1 km clean underscore h dot pdbqt. We are going to save it. So now, no, yes, we want to put. So now what we can say, okay, in our virtual screening folder, what has been there, all the PDBQT format of both the ligand and protein configuration file is already there. So what we will be needing more, that is this Vina exe and this Vina file. Okay. So now the next step is to perform the virtual screening